Okay, in this video I will talk about how the Monty Hall problem applies to the game of poker. In the previous video, I described to you the Monty Hall problem and its game theoretical as well as probability solutions. When we are applying it to poker, we will first discuss the probability solution because the game theoretic solution in poker gets quite complex as players try to guess each other through various facial expressions and various other means. So, but for the probability method, let's say that we have pocket jacks and we are afraid that some of the other players might have queens, kings, or aces. And if they flop a queen, king, or ace, then they might beat our pocket jack with a bigger pair. So we have an estimate of the probability that one of the other players has a queen, king, or ace, and we believe that that probability, let's say, is X. Let's say that there are 5 players that play before us and 1 player that plays after us. So on the flop, let's say a queen shows up, and so now we narrow it down and we have to decide what is the chance that one of these players has a queen. So let's say it's x over 3 because there were 3 cards before, queen, king, or ace, and now there's only 1 queen on the flop. So x over 3, but this x over 3 is amongst the first 5 players and then the 1 player who plays after us. Now, based on the Monty Hall problem, we know that the total probability will have to continue to be 6 times x over 3, which is 2x amongst all of the 6 players. So let's say that the first player checks, the second player checks, the third player checks. So what this means, if we believe that they're checking because they don't have a queen, what it would mean is that 2x probability has transferred to being the sum of the probability between the 2 players that are playing before us and the 1 player that's playing after us. Let's say the other 2 players also check. So now we know that the probability that the player that will play after us is holding a queen is exactly 2x. So this leads us to conditional expectation, and we have just applied it to poker. We now understand that just because the first 5 players folded does not mean that the total probability of somebody having a queen went down. It simply shifted to all of it being with the player that plays after us. That means it's very likely, depending on the value of x, that that player that plays after us will actually show a queen. And we should proceed carefully. So we may choose to check with our pocket jacks, and you will see that most of the time the player that will play after will make a bet. So when that player makes the bet, you know exactly how likely he is to have or not have the queen. So that is how we apply the Monty Hall problem to a game of poker.